So in this case, the x component will be cosine, and we only care about x component since y component will multiply by 0 anyway. So we get it is a times cosine times the magnitude of b, or we say the dot product between two vectors will also be the product of their magnitude, but with a factor of cosine. This cosine is the angle between the two vectors when you are touching tails. You need to first touch their tails and then look at the angle between them. Okay? So dot product is just like modifying the magnitude of vectors, but the direction of the vectors matters. If the direction, if the relative direction between two vectors are different, then this cosine will be different and the result will be different. But you see it is a product because you are multiplying the magnitude of the two vectors. This factor of cosine is important. Let's say I am pulling a thing with this force, and I move the thing with this displacement. Now, is the angle between these two vectors bigger or smaller than 90 degrees? Smaller. So if the angle is smaller than 90 degrees, will cosine be positive or negative? It's positive. It will be 1 when it is 0, and it becomes 0 when it's 90 degrees. But anyway, it's going to be positive. So the work done by this force will be positive. And work will change your kinetic energy. If work is positive, the change of kinetic energy will be positive. If the change of kinetic energy is positive, does it mean the kinetic energy will increase or decrease?
Increase.
It will increase, good. So you see, if I am pulling a chair with an angle that is smaller than 90, I move it at displacement, it gets kinetic energy. Initially, the kinetic energy is 0, but after I pull it with a force, making a smaller angle than 90 degrees with the displacement, it gains kinetic energy. So if the force is pulling along or about the same direction of the displacement, you do positive work, and your work will increase the kinetic energy of the particle. Okay? Let's look at another example. If I'm pulling in this direction, and the displacement is again to the right, is this angle bigger or smaller than 90 degrees? Bigger. And will the cosine of that angle be bigger or smaller than 0? It will be negative or positive?
Negative.
It will be negative. So in this case, the work done by this force will be negative, and the kinetic energy will decrease. Let's look at this example. Initially, it's moving, but I pull it backward in the opposite direction of its displacement. Then you see initially it's moving, then I pull it, then it stops. The kinetic energy decreases because the work I'm doing is negative. The work I'm doing is negative because I'm pulling in a direction that is kind of opposite to the displacement. The boundary between positive at negative is 90 degrees. When it is smaller than 90, then you are basically pointing in the same direction, increasing the kinetic energy. If it is bigger than 90, you are basically kind of opposite, and you are decreasing the kinetic energy of the particle. But the energy does not disappear, it's not destroyed. You are not destroying energy, you are just taking or inputting energy to the particle. If you do positive work, energy goes from me into the chair. If I do negative work, energy goes from the chair to me. Okay? So this is why we want to change the work, which is fx delta x plus fy delta y into the magnitude times cosine theta, because this cosine theta is useful. It just tells us if they're in the same direction, you do positive work. If they're opposite, you do negative work. And if they are exactly 90 degrees, like when the sun is applying gravity to the Earth, and if the orbit of Earth is a perfect circle, the velocity is going up, which will be the same as displacement. The direction of velocity is changing every time, but at every instant, gravity will always be perpendicular to the velocity. So the displacement between two states will always be perpendicular to gravity. When force is perpendicular to the displacement, the dot product between them will be 0. So gravity will do 0 work, and the change of kinetic energy will be 0. You cannot change the kinetic energy of a particle by applying a perpendicular force. So this is why the kinetic energy of this Earth can be constant, and so its speed will be constant. This is why when you apply a perpendicular force, the speed will not change, because you cannot change kinetic energy by applying force perpendicular to the displacement. The work done by perpendicular force will be 0, because the dot product is 0. Okay? Now let's look at a very life-saving example. If you are driving a car, and initially your car is at here, then you see something, so you need to emergency brake. You need to brake immediately. And when you brake, friction is going back. Initially, you have a speed v moving in this direction, and you want to hit the brake, but you will not stop immediately. You need to slide for a distance before your car comes to a complete stop. And this distance better be the safety distance you are making with the car in front of you. So now we can use work kinetic energy theorem to calculate this distance. Initially, the kinetic energy is 1/2 mv squared because the initial speed is v. The final speed is 0, so I don't need to do vi, vf. I just do v and 0. The final kinetic energy is 0. So the kinetic energy is changing. The change is final minus initial. So the change is negative, which means the kinetic energy is decreasing. To decrease kinetic energy, do you need to do positive or negative work?
Negative.
Good. And to do negative work, should the force be in the same direction or opposite to the displacement? Opposite. So you see, indeed, friction is going back, but you are sliding to the front. They are opposite in direction, so the work done by this friction is negative, which makes sense for decreasing kinetic energy. The work, in this case, is done by friction. So, because they are making a 180 degree and cosine 180 is that something you guys should know? So cosine is defined as here. So if you have a circle, and here is x position, y position, your radius is r, here is theta. Cosine theta is defined as the x position divided by radius r. So when you go to the other side, which is 180, the x position will be what? What is the x position of this particle at here if the radius is r?
Negative r.
Good, negative r. So cosine 180 will be negative r divided by r, that's minus 1. Okay? So cosine can go from 1 to minus 1. And when you have a opposite direction, cosine gives you minus 1. So this is why you have a minus sign between for the work. The magnitude of